you know, how can I say this? We'll print the starting and the ending asterisk, and then we will finally print the bottom row. Okay, and since this is in a loop, we don't want to print one of the two border lines for every element. We want to print one of the two border lines for every height number minus 2, because we're printing the top and the bottom parts. So this height being at least 2 or higher will prevent this range from starting out at negative numbers. You see how that works there? We're using this exception to exit the code before we get to a condition down here that would make basically a nonsensical box. Okay? And so we can jump through all of this and get down to where it's being called. And you'll see that here, what they're doing is they're using the multiple assignment. The asterisk is going into sim, the 4 and the 4 are going into the width and height respectively. And then this will be the next one and the next one and the next one. And we're going to try to use this box print function in order to print out our box. And if there was an exception, then we will capture the exception into the variable error, ERR. Okay? And we will say an exception happened, and then we will basically coerce the exception, the error, into a string by using the string function and print out an exception happened in the text of the exception. Okay? I know that we've been going through quite a bit of Python, and I'm kind of going over it quickly. Is there any points that you don't understand in this example so far? Nope? Okay, because the thing is that it's really the execution flow we're going to be concerned about. We want to see one of these exceptions raised, and we want to stop going through this function and exit on the exceptional item. Since the exception is handled, it doesn't stop the program. It'll just go to the next one inside the for. Okay? So, when we call this the first time, it was a box of 4x4 with asterisks. When we call it the next time, it's a much larger box made out of the number zeros. And when we call it the third time, an error happens. The width must be greater than 2. Because if you'll take a look back up here on the input arguments, the width was 1. Okay? When we call it the fourth time, we get an exception. The symbol must have a single character string. In this case, somebody decided that it would be fun to call it with ZZ. And our function is not equipped to handle width of ZZ. Matter of fact, if you really want the width to be 3, you're going to have a heck of a time with ZZ, because there's no way that you can repeat that in a way to only get 3 characters wide. So the point is that the first time we call through this, it goes through all these if statements, and none of them are true. And so it prints the box out. Second time, none of them are true. It prints the box out. The third time, this width, this condition is true. And so we threw this exception by raising it. We raised this exception and stopped normal processing. Because this exception was captured, a print happened, we did not die. If there was no try except here, it would bubble up and stop the entire program. The fourth time, we went through, and this time, this statement was true. And so we raised this exception. And so in this way, this is an example of a program that still can continue on, even though one of the functions is getting bad input. So generally speaking, when you see input into a function, I sometimes get the question asked to me, how do I know if I should raise an exception or simply just handle it with like some error correcting code? The answer to this question is a little bit dependent upon what you expect. Sometimes when you're reading things in, you expect bad input. If you expect bad input from a user, don't throw an exception. Put the handling for the bad input right there. However, if you get something that really you have no idea why it went wrong, by all means, throw an exception. So if you're writing an input validator and the input is not valid, okay, then the code inside the input validator might just return back that it's not valid. You might have a function that says, is this valid, and it returns back false, okay? On the other hand, if you have a form and one of the fields in the form was not filled out correctly, depending upon the logic of your application, you may expect this form to be filled out incorrectly, you may expect it to be filled out correctly. If it's truly exceptional, it's often easier to put the exception flow handling into the structure of Python's exception handling. Okay, but if it's a piece of logic where you're supposed to have all the validation code right there inside that defined function, then sometimes it's better not to throw the exception. Exception handling really should be used for exceptional events. If you assume that this should handle it, don't throw an exception and try to catch it and handle it right inside the block. It just gets a little bit more confusing than it needs to be. Okay. So, what happens when you throw an exception and you want that exception to be caught, but you don't really want to print out all that traceback information to the screen? Well, there's no need to actually print that exception. You don't have to coerce it to a string and print it out. But what you can do is you can capture that information. So here we have a couple of functions. One is spam, which calls bacon, and one is bacon, which raises an exception, and we call spam. Now, when you run this, you're going to get output that looks like this. And it's very important to go through this because this helps you find where the error was raised. At the bottom is the exception. This is an error message. At the top is the top level function, and then the function underneath it, and then finally the function, or in this case constructor, where the exception was raised. So you can see clearly that spam called bacon, okay, it's spam called bacon at line 7, and inside spam at line 2, bacon called this raise, I'm sorry, let's go back up here. Spam was at line 7, okay, it called bacon, and then basically the second line of spam, line 2, called bacon, which raised the exception. These line numbers match up. This line 7 is the spam that's at the bottom of this program. This line 2 is the bacon that is inside the spam block. And this raise exception at line 5 is the actual line of the raise exception, which me just counting line numbers means that there's probably a white space line that got swallowed up somewhere. Okay, but the point is that you can use this traceback to locate how the exception was called. And this is very important because often functions will be used over and over again. When they're used over and over again, sometimes it's important to know who called the function as opposed to just know that the error existed in here. For example, if you had a module that for one reason or another added something, or looked up a user. Lots of things would look up users. Lots of things might add things. These uses where it was called would be probably more informative than the actual this user is not found exception. But going back to how you would capture it, well, if you want to capture the information, you need to basically import the traceback module. This traceback module has the function format exception, except that the difference in calling this format exception is that it will return back the string. You can capture that string in your program, maybe stick it into a database, stick it into a log file. In this case, they are putting the error into a text file. Now, you just covered files not too long ago. You might recall that writing it will take whatever this value is and stick it into the file. And this indicates that the file is writable. You're asking for a writable handle. So here we write it, and then we close it, and then we're going to print the traceback information that was written to this file. Okay? Because the write function returns back how many characters were written, and because we're in a REPL, it's going to print back 116. But the next line is the traceback information was written into errorinfo.txt. And this way you can capture your exceptions, but they're not on the console, they're inside a file. Sometimes it's useful to have these things captured in the files so they can live longer than whatever the screen is on the console. People type into the consoles, it scrolls off. If it scrolls outside of the buffer window, you can't always capture it. Okay, so in this case, if we take a look at the contents of the file, we get the entire traceback output because that was what was generated with this traceback formatting example. And so the contents of the file have the same traceback that we would have normally had printed out to the screen. Okay, who sees what's going on here? Okay, I see a head shaking no. So what we'll do is we'll go from the top again. In this case, what we want is normally when we have an exception, you've got the screen that your Python program is running, right? Okay, and if it's a REPL, you just type in commands here, and if there's an exception, you get some lines back, and then it's time to go again. All right? If this is structured as a .py, and you do something like Python, and you call your module .py, then what will happen is it'll load this and run it, and if you get the exception, it'll print back here, and then you'll get your command line prompt again. Okay? But what we want here is we want this thing to run either way, but we want it to write the exception into a file. Okay? So the important part is how do you get that text that normally is printed out to the console in a way that you're still in control, you're still inside some way where you can grab that text and then decide what to do with it. And the way to do that is to use this traceback module. You'll import the traceback module, and then you'll notice that we don't actually print this exception. We just say, hey, please format the exception for us. That'll return back a string. Once we've got a string, we can do with it what we want. We can print it again if we really want to. We can write it to the file as we're doing in this example, or we could count the characters and say an exception was raised that was 32 characters long. It might not be particularly useful for the user, but the point is that we're still inside our flow control and we can do whatever is necessary. Okay, does that make it a little bit more clear? So in this case, they're opening the file here, okay? And they're opening this file name as a writable file, okay? And so it's that handle, the thing that you'll use to write to the file is stored inside this error file. And so you've got this as a file object, and you use write. So write this line puts whatever this thing returns into the file, and then we want to close the file, which will finish the write operation, and no longer we can write to this file. Now, once this is written, this is how you would access the file on the program side, because there's going to be two people hopefully accessing the file. One is the program writing it. On reading it, you would probably have somebody go in through the operating system's file browser and double-click on the file to open it. Okay, so a good example here is if I were to take a look at my operating system's file browser. And it might be a little bit hard to read because it's my font. I'm not going to adjust the font for my actual operating system. You can see that this would be an aquarium text file instead of the other one. And if I double click on it, then I get the actual text out of the file. So the main point is that by having this traceback module, we can capture the information in a way we can do what we want with it. And that might be writing it to a file, it might be storing it in a database, it might be sending an SMS message with it, it might be whatever it is that you really want to do. Sometimes it's important to get this exception information in a way that doesn't just go to the screen. Okay? So I'm looking for any more. Was that good for your question?
I think so. What do I do?
Okay, so in this case, when they're opening the file, they're not specifying a complete path to the file. So wherever you were running this program, it's going to probably drop the file right there. Not your home directory. If you run the program in a subdirectory, it'll drop it in the subdirectory. If you run the program in your home directory, it'll drop it in the home directory. If you run it in like some other directory, that's where it'll be. And the way that you would fix that is you would, actually build up a known location in your system to hold these files, not just to open the file name, but actually open the whole file path. You're welcome. It's good questions. So that's about all that we have to say about exceptions. You run into an exceptional situation, by all means, raise an exception. Construct one and raise it. Because it's much better to handle things that your code is not designed to handle through an exceptional processing path instead of trying to write it in there. Now, if your code intends to handle this as an error, then it's just data that's going in. Don't handle the data you expect with exceptional processing paths. It becomes very hard to reason about. So, I saw pizza come in. The pizza is gone. What happened?
He was hungry.
Evan was hungry?
He ate all the
I think we moved it next door.
He threw out all the pizza because there
pineapple
was
pizza
pineapple.
in. Oh, he put it in the lunchroom.
Yeah.
Okay, who wants to take a break for pizza? Very well. Then we'll cover assertions right after the food. Welcome back. Okay, well, we talked about exceptions earlier. Now we're going to give you another tool that you can put into your code that will help you isolate errors, and that is assertions. Who's used assertions in any language before? Okay, I see a couple of hands. Fantastic. For those of you who hadn't, an assertion is a sanity check. You want to make sure that some condition that basically never should happen isn't happening. And so what you do is you wind up writing an assertion, and the assertion will make sure your code isn't doing something very obviously wrong. For example, if you had, say, a square root function, you probably don't want to take the square root of a negative number. You might assert that the input is greater than 0, okay? Or at least 0. So the point is that assertions will throw an exception, but they throw an assertion error. And this helps you sort of isolate them from other kinds of exceptions that you have in your code. And to write an assertion, you're going to use the assert keyword, some Boolean condition, okay, a comma, and the string to display only when the assertion is false. So let's take a look at what one of these looks like. Here we go. We have the pod bay doors. Now, for those of you who haven't seen 2001: A Space Odyssey, by all means rush out and see it. It's an excellent film. But here they are going to assert that the pod bay door status is open. And if it's not open, it will throw an assertion error that the pod bay doors need to be open. Okay? Here, they've changed the status to, I'm sorry, Dave, I'm afraid I can't do that. Okay? And then they will run the assertion here, are the pod bay status doors open? Or the pod bay door status, is it open? And it will say the pod bay doors need to be open. So they actually typed the assertion twice, okay? And the first time it should work, and the second time it will say, assert pod bay door status open. This is the line that it got thrown. And this is the actual text of the assertion error. Assertion error, the pod bay doors need to be open. Okay? So it's similar to an exception, but the difference is exceptions are these things that your program is going to basically run no matter what. Assertions have a few extra features to them, which are very nice. Exceptions, you want them to run at runtime no matter what. But with assertions, what you can do is you can actually remove all of the assertions in your code through command line flag parameters that just tell Python to skip over them. And so you can use your assertions while you're developing and debugging, and then you can basically say, without ripping them out, ignore them all, because now it's time to run really fast. And these assertions, because of this feature in Python, you usually want to use them for the kinds of errors that you would encounter while you're developing a program. Exceptions are the kinds of errors you would want to deliver once the program is delivered to your customer. Assertions, you should never assert something that you need it to always throw if that condition happens, because the assertions can be disabled. Okay? And the way that the assert keyword gets its meaning is the same way in English. You're asserting that something is so. You know, I assert that this condition holds true. And if not, then that implies there's a bug somewhere in the program. So you write your assertions to expose programming errors, where sometimes you write your exceptions to expose errors of like where your program runs inside the operating system, whether or not you have a network connection, you know, to a remote server or whatever. These things can be transitional. If you don't have, say, a network connection to your database, that can be fixed. Okay? And so that should be thrown no matter what. But if you decided that, like, you were supposed to find the error, and the error is supposed to be positive, no matter what, because it's a distance away from a point, then if you had a negative error, you might assert that the error is not negative, you know. Okay, so again, like we said, assertions are for programmer errors, not user errors, not situations in the environment that are just unexpected. Okay, and and generally speaking, since it's a programmer error, you really can't recover from it. You know, because that means there's a mistake in logic somewhere else, something's getting passed incorrectly. And so you just basically need the program to die, report where it is really clearly, and then you can go back and you can fix in the call stack whatever it was that passed the bad data in. So we're going to discuss a traffic light simulation. I know, everybody being in Houston, that you all know what traffic lights are. So, traffic light simulation, we have green, yellow, and red. And these lights represent the various states of this sort of modeled traffic light. So here we have two traffic lights. We are basically saying that this traffic light has a dictionary for a value, okay, and that the north-south light, because apparently all of these streets line up very nicely, north and south, east and west, is set to green, whereas the east-west light is set to red. Likewise, on this other intersection, at Mission and 16th, the north-south light is set to red, and the east-west light is set to green. Okay? So in order to be able to demonstrate an assertion error, we need to have some programming to have a bug in. So we're going to talk about this switch lights function. And we'll start off with a very simple switch lights function. And the switch lights function just basically cycles through the colors. All green values change to yellow, all yellow values change to red, all red values change to green. Okay? Now, if we take a look at this really quickly, you're going to start to notice that the green value here will change to yellow in the switch lights, and the red value will change to green. And this would create an unsafe condition inside this intersection, because you'd still have people who are clearing the intersection due to the yellow light while you have a green light in the opposite direction. This is something that should never happen. So what we can do is, first, here's the implementation of switching the light colors. And as we run through it, we'll notice that there are problems. And so what we will do is we will add an assertion. And we will say red has to be somewhere in the values in the dictionary. Okay? Now, this is assuming that there's only two values, so at least one of the lights is red. But the point is that this assertion here will say that the values must contain red, otherwise neither light is red. And if neither light is red, certainly that's a condition we don't want in an intersection. So here we see what it looks like after this assertion is added in to the top of this switch lights function. And of course, it will fail immediately. And it'll say, assert red in stoplight values, neither light is red. This is the line that the assertion error was thrown from. It's an exception. It was raised on this line. And here's the assertion error. Neither light is red. The north-south is yellow, and the east-west is green. So this is a condition that is not appropriate for this program. This indicates that whoever wrote this algorithm for changing the traffic lights really had it out for the people in this intersection. In other words, the city of Houston is hiring. No, I'm just kidding. Anyway, so the point is that this is an example of how you would use this assertion. And we said that assertions have this feature, which is when you're in development, you've got a lot of these conditions you want to check. But when you're running, you don't want to be checking all of these conditions over and over again. The programming logic should be removed by the time you deliver this software to the customer. So what we will do is, because it's an assertion and not an exception or something else, we will disable it. And so over here, you'll notice that there's this -O option. Okay? This -O option is a signal to the Python interpreter that says every time I find an assert keyword like this, I'm just going to ignore the entire assertion and move on. This assertion will not actually be tested when the assertions are turned off with the -O option. Okay? We don't have to remove them from the code. We don't have to cut them out. They'll still be there for when we want to do our development testing. We just take the flag off, and the assertions will run. And the code will go a little bit slower. Assertions are really fast, but they do take a little bit of time. And they'll go a little bit slower without the flag. So does everybody see how they might be able to use these assertions inside some sort of programming environment that they're working on? Okay, I see a lot of heads going yes. Yes, you definitely for development. The assertions, one of the key things is that the error messages are for the developers. So never write an assertion if the error message is intended for somebody who's not a developer. Okay? And instead of going through and cutting out all of the lines of code when it's time to ship it to a customer, you can simply configure the environment to run it with the assertions disabled. Okay? And so they'll still be in there, they just won't actually run.
They'll be skipped over by the Python interpreter. So finally, we're coming up to a very powerful and yet sometimes properly used, sometimes not properly used. There's a lot of opinions on it. Debugging tool, which is logging. Okay, so logging allows you to put output to the screen or to a file or to wherever you want that basically gives you some sort of status or some sort of update to the progress of your code. Now, you will have to write these log statements. These are not things that will be automatically enabled through some sort of a flag. But the point of using logging is that you can avoid the print statement. Why do you think the print statement might be useful to say that it's a warning? It depends on where you make that judgment call. But if, for example, the program fires up and it can't connect to the authentication server to validate any of these credentials, it's not going to be able to progress. It might be more appropriate to throw a critical error. Couldn't connect to the authentication server, shutting down. You know, something like that. So do you get an idea of how you could structure your messages back to, effectively, yourself? Okay? By filtering them out and having very few criticals and errors and more information and lots of debug stuff, you can basically then go in to this basic config. And this basic config, you typically put it at the top of your module. Because when it's time to figure out what's going on, you're going to open up the module, and you're going to change the logging level. And if this module looks like just something you don't really care about, leave it to log like warnings or criticals. Okay? And if this is the module that you finally hunted your bug down to, turn it up to debug so you can get every little bit of info out of it that you had written before. Okay? So here is basically it set a debug, and you can see it prints out the debug. And here it prints out info, and you see that the message is actually tagged with the level. So when you're at debug in the configuration, you can see that this is an informative message. Okay? But then, when you get down here, and after he's shown all of the different formattings of the errors, he's going to, well, okay, he didn't actually show it. Did he? No, he didn't. Okay. Point is that if you wanted to get half of these messages to go away, you would open up your file and change that debug to warning. And then you would only get the warning, error, and criticals. And you could change that logging to make less or more noise depending upon the amount of information you want fed back to you at a time where you're still developing the module. But when you ship it, it's really kind of nice not to have these error messages right there in front for your customer to see. Okay? It should probably be handled at another level. And so when you ship it, you want to change the logging level in such a way that you won't actually see all of these lovely little things like critical error, okay? And so the way that you can do that is you can use logging disable. And logging disable will reconfigure your logging system to basically not put any output out. And since it doesn't have any output out, that means that the legitimate uses of print, you know, will print things, and you won't get all of these little extra logging error messages out in your console. Now, if you don't print it out to the screen, sometimes it's still quite useful to have the information, especially if the customer calls you up and says, hey, it's not working right, I'd like to know why. And you would say, oh, well, you know, you could open up the Python modules and start reconfiguring them, and they will probably look at you as like, oh, how quaint. I don't even have a snake in my computer. You know, and so you just basically, you realize, oh, okay, This is not the way to write software that's going to be used by other people. The right way to write software that's going to be used by other people is to have a log file, okay? Now, this is the Linux users group, so I expect to see lots of hands on this one. Who has ever opened a log file looking at something in it because they were trying to figure out what was going on? Okay, we got about 70% of the class and about 30% of you are asleep. So the point is that this basic config, it has another named parameter called file name. Now, remember that last time you said, well, where are these files? Again, he used a relative based path. So this file will be wherever he wound up running the program. Generally speaking, you want to put these kinds of log files into a directory on the operating system that is sort of known to hold files somewhere under here. Ideally, if your program has a name, under that directory would be even better, okay? And of course, you can use any kind of pathing for this file name in order to make it work on your system. You can use C, Windows paths or regular Unix pathing. You just got to make sure that it'll work on whatever system that it is deployed on. There are even sophisticated ways of building those paths based off of the operating system that you're on. But the point is that this, instead of logging it back out to the screen, will log it into this file. It'll open the file, it'll put the information in there, it'll close the file afterwards, assuming the program exits correctly. And of course, you still set the logging level because it needs to know what level you intend to write to, and you still have format. And if you use disable, it will disable the writing to this file, and you can re-enable the logging later on. But the point is that it just redirects everything that would have gone to the screen that's a log message to this file. And so now we have covered a few of the things that you can actually change in your code to make it easier to maintain. We've covered exceptions. We've covered assertions that are used through the assert keyword. We've covered logging. One of the things that we will now do is we will actually look at what the chapter is titled, debugging, the debugger. Debugging is a process by which you rationalize there's a problem, find it, and fix it. So all of those other techniques are useful for the process of debugging, but there's an actual thing called a debugger. And who has used a debugger in any programming environment? All right, about half of you. A debugger is a special way of running your program. You run it, and normally you run it by running the Python or the Python 3 command. The debugger is like that, except that what it will do is it will stop your program from running and allow you to say when you want the program to move forward. And as you move forward, you can look at all of the variables that are set there. You can look at all of the conditions that you think might be there. You can actually watch the program running in effectively super slow motion, and you can control the speed. You can say, let's go to the next one. Oh, let's skip over 20 and just stop here, and I want to see what it is when it stops here. And in this book, they talk about idle. Okay? Now, you may recall that we indicated that you should have PyCharm installed. Most of the information in this book refers to idle's debugger, and we will, of course, be presenting Python's, the PyCharm debugger. And so all of the functionality is the same, but since we are using a different integrated development environment, some of the presentation will be different, and how it is called will be slightly different. The main point is that inside this running environment, you have various areas of the Python interpreter. One area is called the stack, and you'll recall that as we enter new functions and exit functions, the nesting of the stack changes such that the function we're in is always on the top of the stack, and the function we started on is always at the bottom of the stack. And you just add new functions to the stack and pop them off as you leave the functions. So the stack is very important because it is basically the same thing as the traceback output. But the difference is the stack is what the traceback output is as the program is running. The traceback output is really only a capture of the stack made non-dynamic, non-running for error output reporting. The stack itself is the living, breathing thing that has these functions being added and removed from it. Locals, we talked about locals. They're variables with what kind of scope? I know, it's a trick question. Local scope, yeah, exactly, okay. The source, well, you know, it is about programming, so at some point in time it would be nice to tie it back to the source code we wrote. And globals are, of course, the variables with global scope. Awesome, awesome. So, this is the debug controller of the idle debugger. And what we will see is that all debuggers have these features. It shows the line of code that's about to be executed. Somehow, you can get all of the local variables and the values that they currently have, and the global variables and the values that they currently have. And this is its IDE. You can see right now that they don't seem to have any code loaded into it. You'll also notice that every now and then you'll get extra variables that you don't really remember defining because they're not actually in your code. You will find as you work with Python more and more that just by using certain things like classes and modules and files and stuff like that, there are certain automatic variables that Python adds for you. When you're in a debugger, usually you'll be able to see those automatic variables. Sometimes you have to configure to see them. Sometimes they're presented straight out of the gate. Point is that if you see more variables than you set, this is not an error. This is just a side effect of using the Python language and Python adding stuff for you that you didn't write. The other thing that all debuggers have, no matter what IDE or environment you're in, is the following functions. Okay? You can go, which basically sometimes is relabeled as running, and it basically says, hey, look, I know you were stopped. Just continue on maximum speed from where you were. Okay? We're done debugging until something else happens that puts us back into a debugging mode. You can step, which is, hey, look, this is interesting. I want to see what happens on the next function call or the next line of code. Okay? When you step over, it's almost like stepping, but if it's a function call, instead of doing literally what happens next, which means going into the function and resuming the information being presented inside that function, sometimes you'll be like, I know what this function does. I don't want to go into it. It's in the middle of a loop. Dear God, this loop's got 1,000 iterations through it. I'd just like to step over this function and get to the line right after it. That's the part that I'm interested in. So stepping over allows you to avoid the very literal next thing the Python interpreter will do by completely avoiding all of the items that are inside of a function. Okay? Stepping out in the event that you're inside a function and you realize, no, this is not the part that I wanted to see. I would like to get out of this function without having to step through everything the function does. You know, I just want to get out of this function to the line that was above it in the higher call on my nesting stack. That's what out is. And quit will terminate the program without it running to full completion. You just basically said, okay, I found what I wanted inside this debugging session. I'm not even interested in letting the program finish. I just want to quit real quick, make a couple of changes, maybe debug again. And we kind of covered these. But you see, in covering just them, what we're going to, it kind of misses some of the translation to the PyCharm environment. So let me show you a small program here. Okay, this is a demo class, and basically this demo is an object. The init will be the constructor of the demo. It takes a first name and it stores it in the name under self. So this will say demo Edwin, okay, and then I basically named it really badly, but the main will print out hello and then whatever name was inside the object. So let me fix that because that's just going to be kind of ugly, and we'll say, we'll call it salute. All right. So if I launch this inside my debugger, okay, there are many ways you can do it. One way that I find that's very useful for PyCharm is just to right-click. It brings up the context menu, and I can step through this program. Okay, and you can see right here, this is the highlighted line in which I'm on, and I can actually say, here are my controls. This is the step to the next line. Okay, this is the step into. This is the step into my code, which they're making a subtle difference here. They gave an extra bit of functionality that says only step into it if I wrote it inside this environment. So you don't step into things like the system implementation of print or a library that you're using that's somebody else's. Here we've got a step out of whatever function I'm in, okay? And there we have run to cursor, which is a nice little extra. You can like highlight another line or whatever and then run to it. So over here is the resume execution, and over here is the stop the debugging session. Okay, so if I hit this, boom, I'm out of the debugging session. I can't see any of the variables because I'm not running anymore. If I decide, you know, that really wasn't what I wanted to do, so I will launch the debugger again, which has that nice little bug-looking icon in the menu. And then I say, oh, yeah, well, I know what stopping does. What does running through it do? And bam, I'm done. Unfortunately, I'm done way too quickly because I didn't even get to see anything that was interesting. Oh, I did stop at the breakpoint. I'm sorry. I had set a specific breakpoint, so I just kind of lied. So now I'll unset the breakpoint, which would stop my debugger again, and I'll run through. And now I got the final output, and you see that everything just sort of worked. Well, that's great, but I really would like to see what happens at this point. So I am going to set something called a breakpoint, and I'm doing it by left-clicking in this margin. And you'll see that as I left-click, it will put in this little red circle, and if I don't remember what this red circle is, I can hover over it, and it'll say something like, we're going to suspend the thread of execution at this line. Now if I run it with the little debugger, okay, and I say, let's go ahead and run through this thing, it actually stops the execution on this line. And since it stops the execution on this line, I can basically say, hey, look, these are some special variables. Well, you know, I'm not really interested in what it does inside this constructor right now. So I am going to step over this line. And I go to the line underneath it. All right? But in this case, you'll see that now it shows me this instance variable. Because this instance variable exists within this scope. It didn't exist before I got past this line, but now it does. And I can see down here the value of this instance variable, which is some sort of main demo object at some sort of address somewhere over there. Let's say I'm kind of interested in what this salute function does. I have no idea what this method on this object does, even though I can read it 3 lines up. So I want to step into this. you'll see that my debugger has advanced the instruction pointer such that now I'm inside the salute and I'm about to print this hello statement. Okay? And I'll be like, oh my, I've got this self variable now because I'm inside the object. I wonder what's underneath that self variable. Oh look, there's a name inside this self variable, and it has the type of string and the value of Edwin. So even before this thing prints, I know for a fact that it's going to print hello Edwin. Now if I step again, let's say I'm at the last line, so if I step forward one line or step out of it, it's the same. But just for fun, I'm going to step out of this function and I'm back to here, but I'm back to here after it's executed. Okay? And you can see down in the console, I've got some output. Hello, Edwin. And then finally, I can just, step again. Well, there's no place to go, and so my debugger shuts down and my program has exited, because it got to the end of the logic. So can you see how a debugger might be useful? If you finally have something isolated down to a small region, you can fire up that code. You can set breakpoints in your source code. You can inspect the conditions. You can step through the logic. Maybe you'll find that you're going through a loop that you thought you wouldn't have, or you're not going through a loop that you thought you would have. You can capture that using logging if you had written the logs. But there are some times where you don't have everything logged. And a debugger is a useful tool to fall back on in some situations. Okay? So let's go back to the actual text of the code now that we've kind of resolved how that looks inside the PyCharm IDEs that we are all using. So here we're printing enter the first number to add and capturing that, the second number, and then the third number. And then we're going to print the sum is first plus second plus third. Okay? And for those of you who were paying really close attention, you'll probably notice that something doesn't look right. And when you run it, you'll certainly notice that it doesn't look right. Okay? Because what we did is we were in the context of adding characters to a string. Python's going to try to help us out. It's going to convert the numbers to characters, and we won't get the arithmetic sum. We will get all the characters slapped together. So 532, well, obviously the sum is 5,342. So now we fire up the debugger, and lo and behold, you can see that it's got some of its globals over here. And we're starting to step through their program, and there's the first one. They type in the first number, and you can see over here that as they kept stepping through it, then what will happen is eventually they will start capturing the values in here. So here's the first, the second, and the third. These are being inputted from the console. We didn't try to convert them to numbers. People can type in any kind of text at the console. So while we've been thinking numbers, really they've been typing in characters. That's the reason that it's 5,342. Okay? Lo and behold, we see these values in the debugger. We realize because the quotes around them, they're strings. We realize because they're strings, we didn't get the error that we thought we would have gotten in the print statement. And it all seemed to work, but it all seemed to work exactly wrong. Okay? So then you'd go back and you would actually convert the strings into numbers, perform a numeric addition, convert the numeric value back into the string, and then print it out, and you would get the correct behavior of your program. So that's kind of a hypothetical, well, not a hypothetical, that's an example of a walkthrough in a debugger. Okay? When you are writing your little test programs and stuff and going through your homework assignments that are inside this book, by all means, do not be afraid to use a debugger. Okay? Using a debugger is something that you need to develop skill in. However, if you want to become really good at programming, don't live in your debugger. Use your debugger to spot check stuff when you just really need to see whether or not something's happening in a certain way. Use it when you really have almost no idea of what's going on. But if you sit there and you validate that your program's working correctly by running through it in the debugger for 2 or 3 different kinds of inputs, you're using the debugger in an appropriate manner. It's going to be very wasteful for your time. And what's worse is that you'll never have the kinds of assertions or logging or any of the kind of error reporting that actually pays back automatically time and time again. So who has written a unit test? For those who want to go above and beyond and start doing debugging of small pieces of your program without doing debugging of the whole program, by all means, look into unit testing. It's not in this book, not in this section. It's just something for you to do, above and beyond, and it pays off beautifully. But it's another one of those things where initially people start, well, gee, you mean I had to write the program? Now I have to write the tests to test the program? And the answer is yes. You didn't get into programming not to write programs, okay? The difference is that the unit tests run as fast as the computer can. So it saves you your personal time checking and double checking. But sometimes you don't have a unit test for it. Sometimes you don't have an assertion that made it very clear that something happened or didn't happen. Sometimes you don't have a log message. Yes?
Can you give us an example of a unit test? I mean, I think I know exactly what you mean, but just...
Okay, so let me go back to the IDE. And right here, I've got this little demo module, right?
Mm-hmm.
So let me see if I can create a new unit test. And I don't see how to do it right here, but I'll just sort of fake it by creating a new module. Oh, there it is, Python unit test. And so we'll call it demo test. All right, and so this is the test case. All right, and what we're going to do is we're going to test something. Now, this is sort of boilerplate code. I really hope that you don't name your tests test something, because after a while you won't remember what the something was that you will test. So I am going to say that I am testing the demo salutation. And what I will do is I will say demo equals demo. I've already picked Edwin. I'll just pick Amy. All right, and then I will say that I want to assert equals, so I'm comparing one thing to another, and they better be equal. All right, and so the first... Oh, thank you. All right. And of course, I don't need this sort of stub test to begin with. And now if I run this unit test, it said it failed. And it failed because I did not actually write the unit test correctly. Module object is not callable. Okay, bonus points. Who wants to tell me what I did wrong? Am I missing something here? No, it's a different language. That's a constructor, right? More.
Demo is a class and it doesn't have any set up to pass it at the end. Back in your demo.
I do believe that that's to take the first name right there. It's a good guess.
Do you have to do demo.demo?
Ah, yeah, because... Well, let me try this. Oh, I probably have to set up a proper package on it. Because it's main demo. One more underscore, Edwin.
Yeah, try import demo.demo. Because the demo class and the demo.
Yeah, I don't think that'll work because I think I've got this inside the main context, and so that's not going to work. Yep, it's not in a package, so. Oh well. I've successfully written a failing unit test. You can see the idea here is that what you're trying to do is you're basically trying to take these little snippets of code that you assume should be working correctly, and you have this assertion here that you want to see the output. And so here for like one that's Amy, then this thing should report hello Amy, and if I were to say change this to, you know, Samantha, then you would see when this test runs that the output would say something like, this assert equals failed. We got hello Samantha when we were expecting hello Amy. Okay? And I'll fix this demo test.py and figure out what the problem is with it. And for those of us who go to the bar, we'll see if we can do that there. All right, so breakpoints. Well, I kind of gave away the highlight on breakpoints when I was stepping through, and I said that left clicking can set a breakpoint. If you say that you want to run your, I want to run this one, not that one. So if you say that you want to run it, a particular module, it will stop at the beginning of the module, and you could step through it, in which case you're going to step through all of the definitions. Matter of fact, let's do that real quick. So here it is. It's starting to define the demo class, and it's defining the init function and the salute method on that demo class, and then it's done with the demo class, and now it's checking to see whether or not the name of this execution context is main, and now it's actually inside what we would consider some of the program. All right? The point is that sometimes you're stepping over a lot of stuff, and you don't care. So what you can do, and I'll just stop the execution real fast, and I'll re-debug it, and here I am. Again, I'm stopped, but I'll just run immediately through, and it will stop at wherever I set the breakpoint. These breakpoints halt the Python interpreter at that line, and that will allow you to start your debugging somewhere that's not very close to the beginning of your program, and you can skip over large amounts of program. Okay? And it's a very useful technique. So in this case, he has a very large loop. And because he wants to stop it, he's going to set a breakpoint at halfway done. Because he wants to see it at this 500th iteration of this loop. Now, he could have manually stepped through the loop 499 times and hoped that his reflexes and learned behaviors hadn't kicked in and stepped through it 2 more times and passed the time that he was interested in. Or he could have set a breakpoint on this if 500. You can do this. Matter of fact, in some cases, you might actually want to insert if statements specifically so you can set breakpoints. You know, just an if statement to do something that almost doesn't even really matter just because you want to stop at that number. Some debuggers offer the ability to set what are called watches. Watches are not covered very heavily in here, but what watches do is they will look at a variable, and when a condition happens, they will do something. They'll either let you know that the variable changed, or they may, in some cases, even break the execution of the program and stop it there. The point is that there's a lot of ways in which you can do this. Okay? His way involves having this if 500 and setting a breakpoint. Now, in his IDE, it's a right-click, you set and clear breakpoints. In ours, you left-click on the margin, you set and clear breakpoints. You'll probably wind up programming Python one day in an IDE that is not PyCharm. Whatever it is in that IDE, if you're going to be doing some debugging, it's worthwhile to go through and find out what these major functions are and find out how you use them inside your new IDE. And then, every now and then, once you've got those breakpoints set, it's very nice to not stop at them anymore. And so you would clear the breakpoint. I'm curious if you can set the breakpoint through the pop-up menu. Okay, this one just doesn't seem to, if it has it, I don't see it. Okay, but anyway, all of them have different ways of setting and clearing breakpoints. So we've seen a few different techniques for isolating, narrowing the scope, identifying, conditions that are unexpected, identifying things that shouldn't happen, how to weed through a bunch of code, hopefully down to a particular line that you're interested in, how to log using logging the values as they're changing, and now we've actually seen how to, even if you don't have all those facilities available, literally stop your program while it's running and take a peek under the covers and see what the values are set. These are the major techniques in debugging. Okay? And these techniques span most languages. Sometimes languages don't have support for things like debuggers. It's pretty rare, but sometimes they don't. Sometimes languages don't have support for various other things. But the point is that these techniques are common, so get used to them. If you know them in one language, there's probably a facility or something very close to a facility that does it in another language. Learn them. Learn when to use them. Learn how to use them. They will make your programming so much easier, only at the side effect of making you do even more programming. But hey, you're trying to get good at programming, nothing like a little bit of extra practice. Okay, so let's go through the practice questions real quick. I know it's 8:30. I know we only have a little bit of time, so we're going to see if we can plow through them. Most of these are super easy. All right, so who thinks that they could tell me about an assert statement that triggers an assertion error if the variable spam is an integer less than 10? So I'll give you a hint. There's that assert keyword. What goes next?
Spam greater than equal to.
Spam.
Greater.
Oh, greater than, sorry. The alligator eats the big thing, right? So spam greater than 10. All right. And then what would we put here? Spam is less than 10. Blah. Awesome. All right. What about if eggs and bacon, which are variables, contain strings that are the same of each other, even if the cases are different? What's the first word? Okay, good. Even if you can't do any of the other ones, the first word on an assertion will be assert. So here we have eggs. Was it bacon? Lower. And then a comma. And then some sort of string that basically, spits out something. Write an assert statement that always triggers an assertion error. Well, there's an infinite number of those.
Assert true. How about assert false?
So that's a very interesting question. All right. Should it be assert true? Should it be assert false? It should be assert false? Or should it be assert true?
Usually your assert statements make a little more sense, like assert there's money in the bank. So usually you're not doing these weird little esoterics.
Yeah, you're not. So if spam is greater than 10, that means, let's say spam is 27, right? 27 is greater than 10. This is a Boolean expression, right? And this Boolean expression evaluates out to what? True. So it's actually not assert false. It's assert true.
No, it is assert true. It's that always triggers an assert.
Oh, I'm sorry. Then did I write this one backwards? Or did I just read the question backwards? Okay. I'm still thinking of it backwards is really what the problem is.
Writing assert that would trigger.
Yeah. So yeah, it's assert false. But a lot of times, if you're in the middle of it and you're programming and you get these little weird problems, I'll give you a programming, truism that almost always you'll see people use over and over again because it's a lot safer than having to rationalize between true or false.
That's the opposite.
Sorry. There you go. Fine. What's really confusing is different libraries use different conventions. So some of them like to trigger on true and some of them like to trigger on false. And once you get enough languages under your belt, then you just truly get befuddled. But you're absolutely right. One important thing that we didn't cover when we're talking about testing is if you're ever going to write a test, the time that you write it, usually you want to be able to force that test to do something. You want the test to fail before you want the test to pass. Okay, because you'll find that you'll have a bug in the test. And if you didn't make that test fail, then you didn't detect that bug. Okay, so fine. Let's go to the next one. What are the two lines your program must have in order to call logging debug? Import line, good. And some sort of config line, right? Yeah, you can use basic config. There's other configs too, but you've got to configure it. Okay? What are the 5 logging levels? I think you're thinking of debugging in the IDE. Okay? Very good. You hit them all. Very fast. Not very loud though. I'll repeat. Debug info warning, error, and critical. Thank you. All right. What line of code can you add to disable all of your logging messages? Let's say you're getting to a critical section where they're about to type in the password and you'd like to not log it back out to the screen. Disable, very good. It's the disable function on whatever it is that you set that logging object to. All right. Why is using logging messages better than print? I know we belabored the point, but let's belabor the point some more.
Removing those print statements is dangerous to the actual function.
One of the many good answers. Yes?
Because print statements go to standard out, and logging goes to standard error. The higher level logging.
Depends on how you configured logging, but that can be very true too. Okay?
Logging should go to standard. Or to a file.
Or to a file. Or, well, I mean, logging messages go where you want them to go if you configure it right. And print statements don't. And there are legitimate uses for print statements, and it's nice not to have to sort them out afterwards. Okay. Now we go. Here you go. Your moment for glory. What's the differences between step, over, and out? Or step, step over, and step out? Right? The next line in whatever level you're in. What does step do? If it's a function. Yeah, it goes into the function to the next line on the function. And what does step out do? Exits the function. Now, does it exit the function by wherever you are in the function, it just jumps straight back out? Or does it exit the function by running to the end of the function and then stopping at the next line? That's a good question. It finishes the function first, because if it doesn't finish the function first, maybe some of the computations aren't done. So it actually does execute the lines underneath to finish up the function when you step out. Yes?
So they're not showing the step in, because most debuggers will have step, step in, step over, step out.
Yeah, and they're matching the terminology for their IDE, which is not our IDE. So like right here, you can see that this is step over. And they usually have function keys assigned to them, so you can do this really fast. The idea is not to be clicking these buttons over and over. Do get used to the function keys. And they're somewhat standard amongst most of the major IDEs. Like F8 is almost always step over. And F7 is usually step in. But the point is that step over, they really clarified it by trying to show that it went kind of like, I don't know, up and over something. And whereas their step in is just simply an arrow down. Okay? But the point is that if I go over here, they actually say step into, which is a lot better than just saying step. Because, you know, you want to know where you're stepping. And yeah, so anyway. Okay. So after you click go, which is run in our IDE, in the debug control window, when does the debugger stop? And there's multiple correct answers to this. I'm just looking for the first one. Okay, well, you hit both of them. Awesome.
What was the answer?
The next breakpoint or the end of the program. Okay. What is a breakpoint? It's a location where you've said you want the code to stop executing. Now, if you set a breakpoint and you run the program, will the program stop at that breakpoint? Nope, it won't. Unless you launch the program with a debugger. Okay? Breakpoints only affect debuggers. You don't have to worry about going through and clearing all your breakpoints in order to like package up the code and ship it or anything like that. That's true. You can set all the breakpoints you want in code that you'd never actually run through, and your program will just happily run around them. Okay? And how do you set a breakpoint? That's specific to an IDE. We're not doing idle, so let's just blow straight past that one. So here's a little coin toss program. You know, I like to not go into too much detail on some of these programs for the people who haven't done them. But if you really want to, give it a go, and you find out that somehow the debugging is churning out in a way that doesn't make any sense to you, we do have the Discord channel. You can post your questions there, and if we have enough people who complain that this was just too hard to understand, before we start the next class, we might be able to field a few questions as we're setting up the audiovisual equipment. So that's it for tonight. We got 15 extra minutes. I think I'll let you guys go and see if we can. Yes. Oh.
Multiple people have asked me how many classes does this course last, and where are we?
So right now we just finished chapter 10. We'll be going into chapter 11. And I believe there are still 10 more chapters, but you can look at the table of the contents in the book. So far, the amount that he writes and the speed of presentation is such that we usually can only cover one chapter a class. So maybe we will get to chapters that are really short and fast, and we can cover 2 of them in one class, but for right now, we'll just rough estimate 1 chapter a week. So we still got a couple months to go. You're welcome.